However, because of this kind of coupled relationship, it led to the development of the next software deployment version, which was virtual machines. So this is the first time that hardware and software were actually decoupled from each other. This means instead of deploying on the hardware itself and the computer itself, software developers would deploy onto a simulated machine called a virtual machine, which would exist and live on the computer. This led to a lot of improvements in flexibility because applications could easily be transferred across systems and upgraded because you only needed to worry about the application or the hardware being able to support the virtual machine. So this meant as long as the computer itself was getting upgraded but could still run a virtual machine, then any of the applications that ran on it prior will still be able to run. And this also goes the same for the software direction. If there are a lot of new improvements for your application design, then you didn't really need to worry about like going past your computer's limits or anything, as long as it still fit within the confines of a virtual machine. However, this solution wasn't really perfect yet, and it always imitated actual servers, which meant there was a lot of overhead behind the scenes, and virtual machines are pretty costly computing wise. So that led to the next big movement, which you guys might also be familiar with, called containerization. And essentially what this was people figured out how to section off parts of an operating system so they could run separate apps on them. This led to improvements in limiting the amount of overhead required in the virtual machine itself, as well as it enabled software developers to more closely match their production environment. So when they're testing the application and developing it on a local or development branch, they're very easily able to mirror their production branch. So software developers were able to ship applications that were more robust and a lot of times more bug-free because they're really matching the same type of deployment that they would actually see in a real world setting. It was also the first time we saw a movement really supported by a robust tooling ecosystem, such as big names like Docker and Kubernetes, which you might be familiar with. But moving past those three prior examples, they all really relied on the idea of where the software was located. For the physical servers, you needed to know that the software was living on the machine itself, and so on and so forth for the virtual machines and the containers. However, when software was developed, or when serverless was developed, it enabled people to really get past the idea of where their software is located and just understand that it was hosted on the cloud, which led to one of the main goals of serverless being providing near unlimited computing power to its users while abstracting away as much of the behind the scenes cloud infrastructure as possible, making it really easy to get big cost savings, have automatic scaling capabilities, and also the reassurance that if it deploys to the cloud, then it can ship pretty much anywhere in the world. So now, what is cloud computing? Well, cloud computing is simply the delivery of computing services via the internet with pay-as-you-go pricing, enabling us and users to access more expensive computing for less money. The three major cloud providers, Amazon Web Services, Google Cloud, and Microsoft Azure, each offer a variety of computing services, each designed with a lot of different best use cases in mind, usually offering the typical serverless advantages of stronger computing power, automatic scaling capabilities, as well as, for the first time ever, paying for the amount of computing you use. What this actually means is demonstrated at the bottom of the slide below, where you can see a traditional server cost would be reflected and demonstrated by that giant red rectangle, because if a company wanted people to access their application, they would need to make sure that the server was running at every point. Even though those 5 instances highlighted by the black squares were the only times that people were actually interacting and using their application, in case someone needed to at any other random point, the company had to make sure that traditional server was always up. However, with serverless, you're able to do real-time computing on a request by request basis, meaning that you only pay for the computing time that you're actually using, allowing people's server bills to dramatically drop. So now let's look at some of the most basic usages of serverless computing technology. AWS Lambdas are Amazon's function as a service option, which is essentially one of the most basic core parts of serverless technology. And what a function as a service is really just a code function that you deploy to the cloud. And then it has a runtime pretty similar to what you see on the right over here. So what that cold start means is it's Amazon Web Services behind the scenes provisioning the resources and doing a lot of stuff that like you don't really need to necessarily worry about, but getting ready for your code to actually run. Then the code starts running, and after that, it sends a response to wherever you called it from, and then it cleans up all the resources behind the scenes, so you stop paying for it after you're done using it. You're then billed by the total milliseconds of compute time and the number of requests that you made to the Lambda. In this instance, you would just see that one number of requests and a 500 millisecond compute time. Another really nice advantage of Lambdas is they automatically scale. So if you call one Lambda and it starts running, you're able to call a near infinite amount of Lambdas, and you could call up to like millions at the same time. And AWS, as long as you're able to fund it, would keep spinning up new instances and keep making sure that the users of your application are getting the best performance possible. Another core feature of AWS Lambdas is the fact that they're stateless functions. So this means that if you ever want to actually keep track of data between the functions, because they will automatically scale and run in their own isolated instances, you need to have some sort of outside connection to a database or like an API if you want to keep track of state and cause meaningful changes through the AWS Lambdas. However, while Lambdas are a really nice and easy to use option, this comes at the expense of being viable in some of the following conditions. If you want to have a program that serves a really large number of invocations, because you pay based off of the number of invocations, it might not always be the most efficient way or place to deploy your technology. Also, currently Lambdas only support 7 languages, those ones listed below. So if you write a program that's not in one of those, then you have to find another place to deploy it. Also, if you have a program that needs low latency, for example, some sort of real-time notification system, due to that cold start runtime that we talked about last slide, Lambdas typically take anywhere from a quarter to even up to a second longer than just the code time running itself. So obviously, if you want your requests to be served as fast as possible, anything that needs to do something to provision extra resources behind the scenes and takes time to set up and then clean itself up after is not really going to meet that low latency need. And the last two limits are on the package size and the runtime for Lambdas. So if you have a Python or any type of function that has a lot of packages and a lot of dependencies, and those dependencies are over 256 megabytes, you have to do some kind of fancy footwork within the Lambda realm to get around that. And if not, Lambdas will simply just not run if you have packages over that size. And similarly, if your Lambda takes longer than 15 minutes to run, they have a built-in timeout feature by that point. So it's not possible for a Lambda to be running for longer than 15 minutes. And one other small caveat is Lambdas will have very different cold start times depending on the language being used. So for example, Golang and Python are 2 very quick languages because they're able to run just in the instance itself. Whereas Java is a little bit slower and has a longer boot time because the Java virtual machine needs to actually take time to instantiate, and then the Java code will start running. So you'll often see cold start times of around like 4 seconds for Java, which can be painfully slow for serving your users. So most people either go for a Golang or a Python Lambda. Now let's take a look at some common Lambda use cases. 3 of the most common of which being APIs, data pipelines, and simply deploying scripts. So for an API, it's as easy as using AWS's API gateway to configure where to send requests. And then you just write the Lambdas to serve as the individual endpoints for get, post, put, or whatever type of Lambda request you need to serve. For data pipelines, you can easily connect to other AWS services and execute code along the pipelines in response to certain trigger events, whether that be image processing or further data processing behind the scenes. Lambdas are a pretty good option for on-the-spot deployment. And then finally, for deploying scripts, since Lambdas are very lightweight and you can just upload a singular function to run in the cloud pretty much anywhere, it's very easy to take any local program and then give it, put it in the cloud, so then you can access it literally anywhere in the world. And with all these solutions, since they're built on top of the core Lambda infrastructure, you'll make sure you'll have a solution that is cost optimized, will automatically scale with pretty consistent performance, and you don't need to worry about that extra infrastructure behind the scenes. So now let's take a quick look at how you would migrate an existing script into an AWS Lambda. So this is what the Lambda page actually looks like within the AWS console. And you just click this nice orange button up here to create a function. There's a couple of options, but typically you just can author a Lambda from scratch and call it whatever. Let's just call this a demo Lambda function. And then you just select whatever runtime you want it to be. You don't really have to worry about permissions or the advanced settings unless you are doing a little bit more advanced stuff, but that's a topic for another day. And then you can just take any script you want and throw it into the cloud. So here's a quick little kind of mock gimmicky chance of rain thing with some mod calculations, pretty fake, but just so you guys get the point of what it looks like. And then after you make changes in the browser IDE when interacting with Lambdas, you always want to make sure you deploy your code. So the code that is actually running at runtime is the most recent stuff. And then after that, you're able to easily test it within the browser IDE by just clicking this orange test button up here. And this will bring up a window at first to configure a test event. And this just lets you pass in some parameters so you can interact and see how the code's actually going to work at runtime. Let's check this out. Oh, and then, yeah, don't forget to make an event name. And oh yeah, you can just do this. And to actually access context and stuff that is passed in through a Lambda, you use the event parameter. So all Lambdas will have two parameters and we'll have this default Lambda handler function. So the parameters passed in are the event, which is just the context, or which is just like whatever parameters you pass into the function itself through that test feature, or when you're calling it somewhere else. And the context will just provide some outside context that will be information about kind of like the time, the specific runtime we're using, in this instance, Python 3.9, and some other good stuff like that. But event is how you access the test variables. Oh, let's see. No, what else?
I think you might go back to
the equal.
How do you have it formatted?
So there's a key error on day, which is kind of confusing. Yeah, I don't know. Sometimes it takes just a backspace and then going forward. But here you can see we passed in the test event number of 10. Then it reads it through the event key that we passed in, just calls this little function down here, gets a random modulus. In this instance, because it was 10, it would return 0. And then you just have that there, returns in the body of this function. And down here, you can see 0% chance of rain. Now, let's give you guys an opportunity to try it out. I'm going to send a link to a Notion page that will have some AWS credentials for you guys, as well as some steps so you can follow along and try publishing your first Lambda and running it. This part can be a little bit tricky, so feel free to just ask some questions and let us know what you're struggling with. Uh, um, does anyone have any questions, or is everyone able to follow along with this?
I'm logged in. I'm making one right now.
Yeah, everything's working well for me.
Oh, actually, I just realized on the test event, you don't need those parameters. You can just pass an empty. If anyone's gotten that far, you can just pass like an empty dictionary. I just edited it. I just edited the Notion page to reflect that. How's everyone doing making the Lambdas? Anyone run into any problems?
I'm all done. It worked well for me.
All right. Yeah, we'll move on in 1 second.
Tim, how you doing?
I've actually been kind of going through it in my head. I noticed that I don't have a username and password, and I wasn't sure if I should use someone else's.
Oh, sorry.
No, it's fine.
I think we made that list based off the
Eventbrite.
that Eventbrite thing. So I just forgot about you there. My bad.
No worries.
Yeah, feel free to use any of the other ones of someone who's just not here. The only issues you'll run into is if you try and log on to something else that someone else is on at the same time.
Yeah, there were some no-shows, so a couple extra usernames out there. Bryce, you want to kind of show what the next part looks like? The
Yep.
flank part.
Tim, you all good?
Yeah, it's fine.
Alright. Then after this, we're gonna hop over to a tool that we've actually been working on over the past couple of probably the past 6 months. Its name's Flank, and it's essentially a interface to easily interact with and utilize Lambdas and all other sorts of backend tasks. So this is kind of what it looks like. You have your task runs and tasks. Your task will be made up of, or is just kind of a blanket term that we developed to sit in front of Lambdas and all other types of AWS and backend cloud services. However, for today's purposes, we'll just focus on utilizing Lambdas. And essentially, after you put in and plug in your cloud providers, you can just click this sync task button. And behind the scenes, it will just automatically log and sync all of the tasks that you've made. So you can play around with any of the Lambdas you've used. And then as to what the process looks like to run a task, you click this run button. Then this launchpad modal comes up, and from here, you're able to just fire off the task just like that. Get a little feedback with a little bubble up in the top window. Then you can see it was just me who was the most recent person who ran this task. And over here, you can see the results of the task run itself. Since we're not actually returning any file data, you don't have access to that right now. But you can just check what time it started at, what time it finished at, and see that it successfully completed. So if you guys go onto that same page again and scroll down a little bit, you can see how to test it out and Flank yourself. You can just use these credentials right here. And if you navigate to the task table, you're able to just click the run button and actually run your first Lambda from outside of AWS, which is pretty cool.
I'm curious, Tim and Chris, I know I talked to you guys beforehand about, some of the things that you're thinking about using serverless for, whether it's Lambdas or just serverless more generally. I'm kind of curious what are you thinking right now? Like, are there specific things that you'd want us to kind of drill down on more specifically?
For me, it's more so that I don't know enough about Lambdas to, kind of figure out what I want to replace and that kind of stuff. But essentially what I was thinking is, there's cases where I need to pull from a certain API. If it's straightforward enough to just, insert into databases, and it's important to know how easy it is to connect to databases on servers that I own versus AWS database servers. That could potentially be nice. I noticed that Bryce mentioned there's like a 15-minute runtime limit. So
Yeah.
like that we could potentially run into, but at the same time, I'm kind of understanding it would be pretty straightforward to just kick off another task immediately afterwards if I really needed to, if it's something that does take more than 15 minutes. Kind of like he was mentioning with like the 256 megabyte like limit, there's probably ways of working around it, kind of the same thing. So yeah, like accessing data from APIs and putting it into personally owned databases, potentially scraping HTML, that kind of stuff. Is that something that's pretty straightforward to do? Like, I know in C# what I would use is HTML agility pack for like pulling HTML and and parsing it. But yeah, I don't know if it's recommended to use Lambda for it.
Yeah, I think the big improvement you get is really cost. I would say the developer experience, I don't know how much we got a little taste of it today, but it's still a little clunky. And then obviously there are some limitations around it. So yeah, I don't know. I think it's almost easier to define what you shouldn't do with it, which is, things that have really large dependencies where you're running into that 256 megabyte limit, things that have a long runtime where you're running into that 15-minute limit, things where if you're running at massive scale, things where you're processing a lot of requests because you're getting billed by the request, or the invocation is what they call it. So I think it's really ideal for these kind of like one-off scripts and things like that, where you just want to give AWS a piece of code and not really worry about containerizing it or setting up a VM or something like that for it to run on.
Yeah, like I think I mentioned to you, I was using Azure's version, which I think is just, I can't remember what it's called, but yeah, I just
call
did
it
like
functions.
yeah,
if I recall correctly.
Yeah. I did that, like you said, it's kind of like a one-off thing where we had a unstable website that we were hosting. And so we just had a function that would run, every so often, just doing a health check, and then just email us or, a group of us when it's down. That way we'll know when, something's wrong. So like that was, I guess that's kind of like a decent example of, a use case for it. I mean, obviously that's not going to be a common use case because why would you be hosting an unstable site? But you know what I mean?
Yeah, it's also, yeah, I agree. And another way to think about it, I mean, Bryce had an API in the slides, but you can almost think of it as, a lot of times people will deploy little functions here and there in API endpoints. And this is sort of a different way to think about it, where it's like you deploy each individual endpoint almost, and then you have the flexibility at that point to kind of wrap those in an API. Like AWS has some other tools, and Azure does too, where you can put, like a routing system on top of that so that, like certain HTTP calls are just routed to specific Lambdas. But you also have the flexibility of kind of doing other things with them behind the scenes. So I think that's kind of, from the standpoint of it kind of changing the way that you think about software development, which is probably like the most powerful part. Like I think that's kind of the most interesting part of these serverless functions.
Yeah, that does sound pretty cool.
Yeah, and then also like you are limited by like the number of invocations and stuff like that. But the free tier for AWS, if I recall correctly, is about 1 million invocations a month. And it's something like 400 million milliseconds of compute time. So it's relatively generous. And like if you are running stuff, you have definitely some runway and area to play around with and maybe like mess up a little bit, because that happens certainly pretty often with serverless technology. And like if you have more specific questions about getting around the package size limit or getting around like that runtime, we did like an advanced workshop earlier today, and we've been doing a lot of research into that area as well. So we'd be happy to answer some of those questions too.
Nice. Is there anything like I was mentioning when I use C# to parse HTML, I pull in the HTML agility pack NuGet package. How straightforward is that kind of process? Like pulling in NuGet packages or JavaScript, pulling in an NPM, pack, like, is that easy, or is that something that's more difficult because you're on a serverless kind of framework?
So it typically is a little bit of a frustrating thing to do if you do it the original recommended way. However, in the past 2 years, Amazon added a feature called like Lambda layers, which is essentially a little bite-sized piece of code that you can plug into any of your Lambdas pretty much anywhere they are. So for instance, we were playing around with some layers earlier today, and we made like a layer is essentially just a zipped up piece of code that you can upload and reuse over and over again in all of your different Lambdas. And it kind of works in like a plug and play fashion. So any Lambda that has a supported runtime for the layer, you can easily just go over here, click add layer, and then this is essentially how you would import the packages. So let's say you wanted that like kind of netscaping or like web scraping C# library that you're talking about, you would zip that up from your own personal CLI and upload that to AWS as a Lambda layer. And then you would be able to, anytime you wanted to use that package, you would just import it as a layer. And then up top, it would just be like importing whatever the name of the function was. Like if it was like that net scraper or whatever, like you just do that. And then it would be really easy to just start using it. That's essentially kind of the recommended workflow for doing any libraries that aren't built into the specific runtime. Python, Golang, like each of the languages has some standard libraries built in. Like I think Python has like JSON and a couple of other ones. So you'd have to do a little bit of research to see if C# has that natively supported. But if not, I would recommend going the Lambda layer route. And another cool little bonus of going that route is if you remember when we were talking about briefly that cold start time, that occurs when Amazon is provisioning extra resources behind the scenes. And Lambda layers, because it's the same code snippet, if you run 10 different Lambda functions that all use the same Lambda layer, they'll each run with what is called the opposite of a cold start, like a warm start, because some of the resources were already provisioned and ready to run, which means that any successive runs will actually end up costing you a lot less money, which is pretty cool as well.
Nice. And I'm guessing that those layers don't add up or combine to create the size limit or to hit the size limit, like each.
So
unfortunately they do.
Oh.
So
yeah.
Okay.
but there's also yeah, once you start getting into these edge cases, it gets a little more complicated. There is a way to now, let me see if I've got the link pulled up. They've recently added a way to just hand a container to a Lambda, which kind of starts to get away from like the original motivation for a Lambda in the first place. But at that point aside, maybe you're fully on Lambda and it's like you have this one extra thing that you want to put on it, in which case that might make sense. But that setup has a higher limit. I think it's like 10 gigabytes. So if you've got it in a container, they relax those constraints for reasons I don't fully understand, to be honest.
And then the other solution for that is you're able to just deploy a zipped up file to Lambdas, or you can store like a zipped up version of your libraries or dependencies in S3. And then one of the packages that's supported by default in all of these AWS runtimes is like the Boto 3 package, which is essentially Amazon's way of interacting with a lot of AWS services. So you can import Boto 3, and then you would do something that's like a Boto 3 like S3 call to get whatever that package is. And then you could unzip it from there too, and then start using it if you want to get around that limit and still use an uncontainerized version.
The problem with that is that you have a lot of kind of boot up time at the beginning, because you got to go grab the package, unzip it, that type of thing.
That makes sense. I only had one more question. Sorry for taking so much of everyone's time.
No, all good.
But is there like a good like list, or like just if you have an idea of what a good list of use cases are, or if there's some website that has like a good is a good resource for hey, these are all these little tiny projects that I've created in serverless functions or something along those lines.
We've actually been compiling like a list of some good use cases for it, as well as some of like resources where we've learned some of the tips and tricks about utilizing Lambdas, but it's not quite finished yet. So we can share that with you and anyone else who is interested in it in a couple of days.
Awesome, thanks.
Anyone else have any questions?
Chris, we didn't really get into the CI/CD stuff very much.
No worries. Yeah, I was just wondering, like, right, or do you have plans in the future for something that's like, triggered from outside of Flank, but to still like be able to show those results and like pull that down from within Flank?
Oh, on the Flank side, so basically
like, for example, using the like CI/CD example, right? Like if you had something tied in with GitHub or something, so that when you make a commit, it like kicks off a build and test, right? And then but it's let's say it's a Lambda run, right? So would like the results from that still be able to be seen within Flank, or is that only for things that that like you personally like kick off from within Flank?
yeah, I think there's, let me see, Bryce, can you enable screen sharing for me? It'll be easier to explain on just using a diagram real quick.
There you go.
What do? Can I do a whiteboard slides? Well, it's not letting me do a whiteboard, but that's okay. I'll just explain it. Like, so basically you've got like the client AWS environment. So that would be your AWS environment. And Flank is like a pretty lightweight app that's sitting on top of that and it's talking to it. And so if you were to just like go directly into your AWS environment and trigger a Lambda, like Flank wouldn't have any awareness of it, at least the way it's architected right now. But what you could do is like, you could just hook into the Flank API. It's like we basically have like a website sitting on top of an API. You could just like hook into the Flank API and then call that Lambda through there, in which case you can see everything up on Flank.
Yeah. Because I was just thinking like it looks really nice right now. It'd be great to like have like be the central source of all of the like Lambda runs, no matter like whether it's originated from somebody hitting a button on Flank or some other trigger somewhere else.
Yeah. I mean, it's like kind of shocking on AWS how how like poorly designed it is for, you know, the
Yeah.
actual task of running stuff. Like it's just not, there's like really nothing around that.
Yeah.
So like, for example, like
The other
after
ones
you
are much better.
see it here and like see the results here, if you like click away from this, how you actually are like supposed to get and view the results is like then click on the monitor tab, and then it's like, oh, okay, you can view the logs in CloudWatch. And then you have to sort through all of the logs of like every Lambda in CloudWatch to figure out which is like the run you're looking for.
Oh, wow.
This actually
Pretty
brings
fun.
up another potential advantage to Lambdas, which is logging. So it kind of depends on how your API is set up, but one thing that I've heard from people they really like is like if you like, let's say you normally have an API and you have a bunch of endpoints that are sort of within one application, and then all those endpoints are kind of being hit at once, and your log output is kind of like all these, let's say you have 100 endpoints, like these 100 endpoints like smushed together. If you take those 100 endpoints and deploy each of them to a separate Lambda, all of a sudden your logging is completely separated along those lines. And so that's one thing that's actually, I would say, like one thing that Lambda kind of scores well on in terms of the developer experience. I think it can kind of make it easier to you know, pin things down and separate what's going on. In general, though, I gotta say, like Lambdas are pretty hard to debug, and it's kind of a long feedback loop in terms of like looking at the logs, going and fixing something, and then like coming back and redeploying it. So, you know, maybe something we could go over another time if you guys are interested is kind of like some of the tools that are out there for shortening those feedback loops, and you know, kind of like running stuff locally in like a Lambda simulated environment, and just, you know, pinning that stuff down more quickly. But yeah. You guys have any other questions? Emmanuel, anything from your end?
I don't have anything from my end. I think it's been a good session. Thank you.
Yeah, thanks for hopping on.
Yeah, it was great to have all you guys. As we're just starting out this process, it's definitely good to have some people.
Yeah, and hopefully this was helpful. We're kind of doing this not for ourselves, but for you guys. So, you know, let us know what you liked, let us know what you didn't, and hopefully we can keep putting together some stuff that helps you guys out.
Yeah. And if you guys have any questions or like things that you want us to take a deeper dive on in the future, we're definitely open to suggestions.
Thanks for putting this together. It was great.
Thanks.
Yeah, thanks. This is really cool.
All right. Oh, if everyone else is done and doesn't have any more questions, I think that's the end of the meeting.
Right. Thanks, guys.
Everyone for coming out, and take care. Enjoy the rest of your Wednesday.
Thanks. Bye.
Bye. Thanks for coming out, Emmanuel.